Welcome to ChemVid. Today we're going to be talking about significant figures and how they help us make our measurements honest. Significant figures are how we report the honesty of our answer or the reliability of an answer. So for instance, if I'm looking at this beaker, I can see that, well, if I have water that comes up to like here, I can see that that's probably about 19 milliliters. But I can't say for certain because it could be anywhere between 20 and maybe 15. Do you see how there are the lines between each of these are 10, separated by tens? So that means that I have a shot of guessing within 10 milliliters of the correct answer. Because I know when it's like halfway in the middle would be 25, so I can measure and guess anywhere between 25 and 30 if the water is in between here. So for this one, I can estimate that this must be 15 milliliters, and so this is probably about 19. However, it could be anywhere from 15 to 20 milliliters. So I'm going to write that range right here. Now, if I go over to this graduated cylinder, I can see much more clearly. So I have 10, and then each one of these little notches is 2. So this would be 12, 14, 16, 18, and 20. So if I look, I can see that the line, we call it the meniscus, where the water bends, is just about at 18. So I'm going to record my number as 18 milliliters. And it could be, so I take one of these separations, and they have a separation of 2. So that means I can guess either one high or one low. So that means that I could be anywhere between 17 milliliters and 19 milliliters. Okay? So, there we go. Here I have a range of 2 milliliters. Here I have a range of 5 milliliters. So as a scientist, I know that my graduated cylinder is giving me a much more exact measurement than the beaker. But we don't always know exactly what instrument they used in order to measure a value. So how we do it is we use significant figures to tell people how accurate the measurement is. Okay? All right, so there are a few rules with significant figures, and we're going to get started with those. All right, so on your notes, here are the rules for significant figures, okay? We're going to go over them. I just wanted you to know where they were so you could reference them. All right, so rule number 1, non-zeros are always significant. What that means is that any number between 1 and 9 are always going to have hold or significance, okay? 1 through 9 is really easy to see. It's the zeros that you have the problem with. So if you notice, the last 4 rules are just for zeros. So number 2, zeros between numbers are always significant. What this means is, if I have a real number, which I refer to as 1 through 9, okay, so it could be any number 1 through 9 in front, and then a 0, and then any number between 1 through 9 in back. This is what we call a sandwiched 0, and it always counts, okay? It's always significant. So this number right here would have 3 significant values. We call them Sig Figs. And 1 and 1 always count, and then the 0 counts because it's in between 2 real numbers. The next one, number 3, says zeros at the beginning of a number are never significant. What this refers to is if you have a number like 0.003, these numbers right here are just placeholders. They're just telling you that you have a very small number, and so they never count. The only one that counts in this case is this 3 right here. So this number has 1 sig fig. So any zeros that are just in front that have nothing else, that's just zeros in front, they don't count as sig figs. They're just letting you know how small you are. All right, number 4. Zeros at the end of a number are not significant unless there is a decimal place in the number. For instance, let's say I have 0.010. We learned from rule number 3 that these numbers do not count, okay, leading ones. But this 0 does count because there's a 1 in front of it and there's a decimal place. So this 1 would actually have 2 sig figs. So if you see anything that has any number, 1 through 9, okay, in front of a 0, and there's a decimal place, you know that that 0 counts. All right, last one, number 5. Counting numbers and defined constants have infinite number of sig figs. So let's say that I have 3 apples. There is a measurement of an apple. You can have 1 apple, but that's an exact number. Okay, so this guy, it's like you're writing 3.000000000 because you know that you have 3 actual apples, and the apples don't have to be measured to any significant places. They're already significant because you can't divide up that apple into smaller measurements unless you have like 1.5 apples or 2 apples or whatever. So this guy has infinite sig figs. Another one is saying, for instance, the speed of light. 3 times 10 to the 8th meters per second. We're going to use that one in a couple of units. And this number right here is what we call a constant. It's always the same, and it's always that value. So this number, because it's a constant, it has infinite number of sig figs as well, because it goes out so far. It's been measured very accurately, and it's what we call a constant. All right? So those are the rules of sig figs. All right, over to the left, I've written out 8 numbers. What I'd like you to do is tell me how many sig figs are in those 8 numbers. Okay? And then I will give you the answers once you unpause the video. So pause it and give it a shot. All right, so the first one has 3. The second one has 3 because the 0 is sandwiched in between the middle. The next one only has 1 because these zeros are trailing zeros and they are never significant. Unless I put a a decimal point there, then I'm saying they are. So if there's a decimal point, then all 3 of those are significant. I know, weird but true. So if there's a decimal point, then there's actually 3 sig figs. If there's not a decimal point, there's only 1 sig fig. Trailing and leading zeros are always worthless. They don't have any sig figs. All right, this guy 423 is 3 sig figs. This guy is 1 sig fig because all the zeros are leading. The next one is 2 sig figs, then 2, and then 3 because of this lovely decimal point and this real number right here. So that's what you're going to be doing in your activity today. And as you can see, so here's where you're practicing significant figures. Then it talks about rounding, how to multiply and divide using significant figures, adding and subtracting, and then there's a little bit of practice. So what I'm going to do in this video is I'm going to go over these different steps. If you need help with them, make sure that you check your answers with your actual packet and try to learn these sig figs as best as possible because we use them quite often to make sure our values are correct. All right? So let's get started. The next thing we need to go over is rounding. Okay, so let's say that you have calculated something. You put in, let's say, density mass divided by volume, and in your calculator you get 26.345. And it only is supposed to have 3 sig figs. So this one right here is a sig fig, this is a sig fig, and this is a sig fig. Now, because I have this 4, 5 here, I need to see if I am supposed to round or not. And you guys know the rules. 5 and above, you round up. 5 and below, you round down. So what I'm going to do is I'm going to look at my value over here, this lovely little 4. It's a 4, so it's below a 5, so that means that I round down. So I would write this number as 26.3, and that would be my final answer. So a lot of the times in math, they'll have you round to like the hundredths place, and that's it, like you always run to the hundredths place. Well, in science, our numbers are different. Our numbers reflect values, and so we have to make sure we write them in with respect to those values. So you have to actually look at your number and decide how many sig figs it needs, and then report it accordingly. So that's how you round. The next guy down, we have 37.94. Let's say that I only needed 2 sig figs on this one. I have 1, and here's 2. But when I look at the next number, 9 is definitely above a 5. So I would record this number as 40, and then I would put a little decimal point there, and that decimal point makes this 0 significant. Okay? So that's how we can use the decimal places to make the zeros correct. All right, next and final. This one is 2.675. So let's say I'm supposed to round up to 2 sig figs again. I have this 6 and I have this 2. So I look at the 7 and I'm going to round up to 2.7. And that's how you do it. So from now on, what you want to do is you want to look and see how many significant figures you need and then report it accordingly. And that's what we're going to do next. Alright, the rules for multiplying and dividing. You always look for the value that has the least significance. So in this case, this 2.3 has 2 sig figs, and 4.67 has 3 sig figs. And you always go with the one that has the least. So I'm going to round my answer to 2 sig figs. I check to make sure I don't need to round up, and I don't. So I report my answer as 2.0. Where on this one has 1 sig fig because those zeros are leading. And this one has 2 sig figs. So I would record my answer to 1 sig fig, and I would report it as 1. And that's how you do multiplication and division. You always go off of the least amount of sig figs. Alright, so for addition and subtraction, it's different than multiplication and division. Alright, so there's 2 sets of rules for 2 sets of multiplier and dividing and addition and subtraction. Alright, for this one, I add the numbers like normal, and then you always go off of the the placeholder that both of them have. So in this case, they both have ones, they both have tenths, and they both have hundredths, but they don't both have the thousands place. So I am going to report this number as 3.67 because this guy is above 5, so I'm going to round up, and that's actually 3.69. Sorry about that. So 3.69. Here I do the same thing. They both don't have the tenths, so I can't do that. The closest they have are the ones, and the 4 doesn't allow me to round up, so I would report this as 30 with a decimal point. Alright? For homework tonight, I'd like you to do every other problem. So problems A, C, E, and G. And then we will go over each of these tomorrow in class and finish up the rest of the practices then. Alright, have a wonderful day.